ನಂಬರ್ ಮ್ಯಾಮ್ ನಂಗೆ ಗೊತ್ತಿಲ್ಲ. ಹಾ ಆಯ್ತು ಅಷ್ಟೇ.
Students, good evening. Turn on your cameras. It's compulsory, okay? Fast. Yes, Mithul, what we have to do now? What is this? This account when I enter a password by giving certain details. Yes, Mithul, if you communicate or if you send one message, I can understand. So how many messages are there? Nearly 20. Same message, 20 messages are there, so that I will not replay anything to you. Huh? And that also before starting the class, this much 20 questions are there. Okay, students, some announcement is there. Yeah, I have multiplied it by 10. Okay, Mithul, you have sent it 2 times. I have multiplied it by 10. Okay, yes. Yes, Mithul, we'll give orientation regarding that. Okay, so students, good evening. So welcome to volume 2. And students, some important announcements are there. So for class 10, you have classes in volume 2. 1 minute, 2 students are waiting. Okay, so in volume 2 for class 10, we have only 4 days classes. Okay, so that thing but on Monday, Tuesday, and Friday, Saturday. Wednesday as well as Thursday, there is no online classes for class 10. Students, are you able to hear me? Students? Yes, students, you have mic, okay? Correct? So you can unmute and then you can communicate. So don't send this my yes ma'am, no ma'am, everything, okay? So if you have any problem or doubts related to the subject, then only you chat. Okay, otherwise you have mic and unmute and then tell, communicate. Okay, yes, students. So in volume 2 for class 10, you have classes only on Monday, Tuesday, and Friday, Saturday. What about Wednesday as well as Thursday? It is a holiday. Then don't call. We will not send any messages to you. Okay, don't call that whether we have a class on Wednesday as well as Thursday. No class. Monday, Tuesday, Friday, Saturday. Is it clear? Only 4 days. Then, okay, then from this volume 2 onwards, we are not using Schoology for test or else DPP or else for quiz. Okay, so we are using one more software that is called Ignis, new software. Okay, so but Schoology, you have to check Schoology for some things. That is one is nothing but a calendar. Okay, timetable, calendar in the sense timetable you will get from that, and updates in the sense see weekly one time we'll send, or else we are planning to not to send any link through school, this one means Zoom IDs through Schoology. We will broadcast it. Okay, then Schoology, see in volume 2, so you are using some ID, right? So login ID to yesterday, from yesterday onwards you are using the same login ID, right? So that will remain same throughout volume 2. Okay, 1 minute. So for whole volume 2, you have to use the same login ID. Okay, so therefore we will not update anything in Schoology. We will send only broadcast. Okay, if there is any changes, then we will inform you. Okay, means if we conduct a combined class or else if we conduct some webinar, then we will inform you. Okay, so otherwise throughout this whole volume 2, you have to use the same login ID. Zoom ID is the same, fixed. Okay, so these students are coming late. Okay, so next for the quiz purpose as well as for the DPP purpose as well as for test purpose, we are using Ignis. Okay. So students, we will give 1 day orientation on that. Okay, maybe it's a Thursday, this a Thursday or Wednesday, tomorrow or else day after tomorrow, we will give orientation. So since orientation is pending, okay, you don't have any quizzes today. Okay, after the orientation we will conduct quiz classes. So at that time, what happens actually? See, first chapter is already started. Physics class yesterday started, right? So he did not conduct any quizzes because orientation is pending for you. So now we'll complete one first chapter. That is, see, two subjects are running. That is physics as well as chemistry. So in these two, we will complete one full chapter. Okay, then after the completion of one full chapter, we will conduct a quiz of one full chapter and we will show you the DPP questions. Okay, so in class only, because if you have, since it is a new one to you, new software to you, so if you have some problems, we can solve. After that every day we will conduct quizzes. Is it clear, students? Is it clear? Okay, then don't call every day, ma'am, whether quiz is there, whether DPP is there, whether we have to solve. Don't ask. Okay, so we will give orientation. Maybe, yes, Amit, what is this expression? Remove that. Okay, so now you may have orientation class tomorrow or else day after tomorrow. After that also we were not we means actually we will wait for the completion of one full chapter. After that we will conduct one quiz, as well as we will show you DPP questions in class only. So if you have any problem, we will solve that. And then there onwards, every day quizzes will be there. It will be informed to you later. But tomorrow as well as day after tomorrow, online classes will not be there. Physics, chemistry is not there. Okay. But you may have orientation classes, but we will inform you. Okay. So we will inform you. Then is there anything to ask, students? After that, yes, Mithil, you can check. After that, you can check access. Okay. So if any problem is there, you can communicate through mail. Through mail. Don't call, madam, my network is slow, I'm not able to upload anything. Okay, if you do that mistake, okay, we are not responsible. Okay, internet is slow, I did not update. So you have to update, no? You have to upload the answers. If you say, I did not update, but I submitted, what I can do, or else what we can do. Correct? So if you face any problem, then you send mail. Mail. Okay? Then you send mail. Is it clear, students? Is it clear? Any doubt in this regarding the rules? No. Okay. Yes, students, will continue this one. Email address. Shashanka, you don't have office email? So you don't send any personal mails, okay? So send queries regarding to related to anything, okay? Not a very silly internet issue, ma'am, I don't have internet, I don't send that type of email. So if you have anything major issues at that time, you have to communicate only through mail. That is to not WhatsApp, not WhatsApp. So it is a mail. I'm asking, I'm telling, right? MAIL, mail to the office address, high school office. Okay. WhatsApp is there to just to broadcast, not to communicate. We don't have a sufficient time to chat. Okay. So we are using that WhatsApp just for broadcast. Is it clear? Yes. So today we'll discuss one new chapter. One minute, 1 minute. Yes, sir. It is actually office hyphen high school, office hyphen high school. Yeah, 1 minute, 1 minute, 1 minute. Wait, students. So one important thing is there. Wait. Yes, students. So yeah, office hyphen high school at cflindia.com is the email ID of office, high school office. Okay. So you have to send your queries to this. Okay. Don't send personal mails and all. And don't send WhatsApp messages also. Okay. So now it is clear, right? If you have any problem or else doubt, then you send it so you send mail to this email ID. Okay. Yes. Now we'll start our topic, today's topic. Where you went, Varuna? Ashay, you were there yesterday. You were there in that class, right? Turn on your camera, Ashay. Even Shashank MN was there in that class yesterday. Correct. You have a confusions in your class?
No, ma'am.
Shashank
I
MN
was
or else
there in
Shashank?
this class from the
This
first.
class only. What about Shashank V? You were there. One Shashank was there. So I was wondering. So whether it is a KC batch or else AC batch. Sorry, AE batch. What about Ashay? Ashay was there in that batch yesterday. Now, if you have this much of confusions, I can't do anything. Okay, I'm helpless. Yes, students. So topic is nothing but a periodic table. Okay, or else a periodic properties. Students, write everything. Note down important points. So we'll distribute books, okay, by this weekend. And once again, don't call. We will send a broadcast message when to come and then when to collect and all. Okay. Yes. So periodic properties, students. today we'll discuss something about periodic table. So you have to communicate, students. So how many blocks are there in this? Do you know anything about this periodic table?
4 blocks.
4 blocks. Yes. So what are those?
SPDF.
Okay, let me write. So 4 blocks are there. That is S block. Write all these things. Okay, then it is a P block and D block as well as F block. Okay, S block, P block, D block as well as F block. So now, students, you just yeah, this is a periodic table. Can you tell me which side S block is there and what's the position of D, position of P as well as F?
S is the left
Students,
of two
yeah,
parts.
left side,
A and
okay,
two.
these two are there, right? So this is a S block element, okay? So this is a S block element. And what about this? So from here to here, so this much is nothing but a P block element, okay? This is a P block element. Then from here to here, so this is a D block element, okay? Then from here to here, means these two rows are there, right? So it is a F block element. So students, how to draw? So this is a periodic table. Okay, then 2 more lines are there here. So this is a S, this is P, this is D, and this is EF. So we'll study it in detail now. Students, turn on your cameras. Otherwise I will throw you out. Okay. Yeah. Who is this? Amit. Your camera is proper. I know that. Chirag, Vivek, and one more. Yeah, Vivek, Chirag. Who is this? Shashank V. Pujari. Yes. So now, in case of the definition of all these blocks, okay, 1 minute. Students, yes, block elements in the sense there, in case of you take any elements of yes block elements, S block section. So what happens? Electron means last electron. See, last electron is also called valence electron. Valence electron. Electron, let me write it as E minus. It's a electron. Okay, electron is a negatively charged species, right? So I will write it as E minus. So what do you mean by valence electron? Valence electron is nothing but last electron. Last electron enters into S orbital. Okay, you write all this words. So 1 minute. Okay, last electron enters into S orbital. Okay, S orbital. So that is the definition of ES block elements. No, unstable. Okay, Anish. So now, what is the definition of P block then? I'll remove everything. 1 minute. I'll write once again. So here you have 4 sections. S block. In case of S block, last electron enters into S orbital. Okay, S orbital. Now, what is the definition of P block? So P block is nothing but same thing. Last electron enters into which orbital, students? Enters into, yes, you have to communicate, P orbital. Okay, enters into P orbital. So what about D block? D block in the sense last electron enters into D orbital. Enters into D orbital. So in case of EF block, last electron enters into F orbital. Okay, last electron enters into F orbital. Is it clear, students? Definitions? Yes. Now, coming to the positions of this S, P, D as well as F, S block is there at the left hand side part. Okay, so left side. Then what about P? The position of P, it is a right side. And what about D? D is in between S as well as P. Okay, so in between S and D, S and P. Okay, you write like this, in between S and P. What is the position? So where this F block element is there? It's a bottom of the periodic table. Okay, bottom of the periodic table. So this is about the position of SPDF. Okay, so then is it over? Did you write all these points? Okay, so now students, yes Pratyusha, what are you doing? No, nothing. Yes, students, n is equal to 1, you write n is equal to 1. So n is equal to 1 is called, you just for an example, okay, I will explain it in detail later. So this is a K shell. N is equal to 1 means it is a K shell. N is equal to 2 means it is a M shell, sorry, KEL shell. KEL shell. Okay, then n is equal to 3 is nothing but M shell. N is equal to 4, KLM En shell. Okay, so and so on and so on. So you can go up to 7. I will explain what is that. Okay, so you have different shells. Okay, so K shell, L shell, M shell, N shell. Okay, students, then is it over? Did you write all these points? Okay, students, I'll take one atom now. See, you take one atom, it contains so many orbitals as well as shell. Okay, so for example, so how to connect, okay, so before that, let me tell something about orbital, students. So you have 4 orbitals, right there only, orbitals. So 4 orbitals are there, that is S orbital and P orbital, and one more is D orbital and F orbital. Okay, S orbital, P orbital, D orbital as well as F orbital. Now Muralidhar, we can place 2 electron in S, 2 electron in S, we can place 6 electrons in P, we can place 10 electrons in D, and we can place 14 electrons in F. Okay, yes, in case of S, 2 electron can be placed. In case of P, 6. In case of D, it is 10. In case of F, it is 14. So why it is 6, why it is 3, why it is, why it is 2, why it is 6, why it is 10, etc. See students, if you consider S orbital, its shape is a spherical shape. Okay, its shape is spherical shape. So this is the structure, this is the nucleus, this is the structure of the S orbital. Okay, here if you write in any direction, you can have only one type of orientation. Okay, only one type of orientation will be there. So you take, see, you take one paper and draw one this one circle here, or else if you do like this and then draw one circle, it remains the same, means only one type of orientation is there. So therefore in one type orientation, if it is there, we can place electron is having the spin up configuration as a spin down one orbital, or else I can write only one box for ES. Okay, so then let me write a P orbital. What is the shape of the P orbital? Dumbbell shape. Students, can you hear me? Students, can you hear me?
Yes, ma'am.
Okay. So students, your talk, okay, otherwise I will be confused whether you are to hear or else whether my internal is I don't. So that fusion will be there for me. So if you don't talk, that will happen. So now coming to this P orbital, dumbbell shape. Okay, P orbital has dumbbell shape. So dumbbell in the sense like this. Okay, you can have 3 types of orientations in this. 3 types of orientations. That is, if I take x-axis, y-axis as well as z-axis, so this is x, this is y, let me write this as x. sorry, Z. Now you can draw dumbbell like this. This is called px orbital, px, because lobes in the sense of this one. Okay, so this is called one lobe, this is one more lobe. Okay, so lobes axis, so it is a px, and similarly you can have two more. So this is z, this is y, this is ex. Now you can write the lobes along y-axis. So this is a py, and similarly you can write one more, so that is arrangement along z-axis. So like this. So now this is okay, so this is a pz atomic orbital, pz orbital. So that means you can write this p orbital in three different ways, that is along x-axis, along y-axis, as well as along z-axis. So therefore three types of orientations are there. Okay, three types of orientations are there. Now therefore see, for one orientation I will write one box, and one more orientation is there, I will write one more box. Okay, one more box for third one. So therefore in case of p, I will write together three boxes, one for px, and 1 minute, I'll write it here. See, one I'll write three boxes, one for px, and one for y, and one for z. Students, in each box I can place two electrons, one with the plus half sign and one more with the minus half sign. So you write 1, 2 here, one more 2 here, two more here. So now you take the count, 2 plus 2 plus 2 is equal to total 6. So therefore together, if I consider this as a p orbital, I can place 6 electrons in this p orbital, 2 in x, 2 in y, as well as 2 in z. Over. Is this clear? Is this clear? Simply, why you have
Yes,
mic, you throw it. Okay, so now the next one is nothing but a d orbital. Students, the next one is a d orbital. So d orbital, its shape is nothing but a double dumbbell shape. Double dumbbell shape. Double dumbbell. That means two dumbbells are there now. So it contains 5 types of orientations. Okay, so in higher classes you will study how to calculate the orientations and all. Okay, so 5 types of orientations are there. So what are those? One is nothing but a dxy, and one more is nothing but a dyz. Okay, and one more is nothing but a dxz. Fourth one dx square minus y square, and fifth one is dz square. So therefore 5 orientations are there. So therefore I will write 5 boxes for d. So now it is 1, 2, 3, 1, 2, 3, 4, 5. So in each box you can place 2 electrons. So total you can place 10 electrons. Totally you can place 10 electrons. So therefore d orbital can hold 10 electrons. Its capacity is equal to 10.
Ma'am, which is the fourth one, ma'am? D.
Fourth one, this one, dx square minus y square and dz square. The fifth one is dz square.
Okay.
I'll show you the picture because you don't have any idea about that. Okay, so did you write all these things? Did you note down all these things?
Yes, ma'am.
Okay, then the last fifth orbital is nothing but F. 1 minute. Yeah, F orbital. So in this F orbital we can place 14 electrons. So that means it shows 7 type of orientation. Okay, it shows 7 type of orientations. That means I can write 7 boxes here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, and one more, 7 boxes. Okay, so in each box I can fill 2 electrons. So totally I can place 14 electrons. And what about the shape of this F? We don't have proof for this. And about the orientation, that orientation dx, y, dy, z, like that I gave, right? In case of a D, or else in case of P, px, py, pz I gave, right? So that type of orientation, we don't know anything about this, okay? So perfect proof is not there for this, little imaginary, okay? So, but you can place 14 electrons here, okay? So I'll show the picture now, 1 minute, wait. Students, so this is a s orbital. So this is the shape of the s orbital. That is a spherical one. Okay. So then, 1 minute. Yeah, this is a p orbital. So this is a px. Just concentrate. X along x-axis lobes are there. Lobes are there along x-axis. So now they have taken this as a y-axis, but lobes are there along y-axis. So it is py. Here it is along z-axis. So it is px. Okay. Then coming to d orbital. See students, so this is a shape of d orbital. Okay, see here xy. So xy, in the sense you have to write the lobe in between the axis, not along the axis. Okay, so two axes are there, right? X as well as y. So you have to write the lobe in between the axis. Okay, then xz, so this is a shape, as well as yz, this is the shape, and dx square minus y square. So here x is separate as well as y is separate. Y is written separately, right? So you have to show the lobes along the axis, Then what about the fifth one? Fifth one is nothing but a dz square. Dz square, this is the shape. So lobes are there along z-axis. Okay, lobes are there along z-axis. Lobes are there along z-axis. So this is the shape of D. Then coming to this F, see F, there are 7 different types of orientation, but still proof is not there. So we are not going to study this F in detail, F orbital in detail. So there are totally 7 types of orientation. So 1, 2, 3, 4, 5, 6, 7. 7 types of orientation. So therefore, you have to write 7 boxes. If you take F orbital, then you have to write 7 boxes. So that for each box you can fill 2 electrons. So the totally you can place 14 electrons. Okay, students. Now coming to this periodic table. So in this periodic table, some horizontal lines are there as well as some vertical lines are there. So can you find out how many horizontal lines are there in this? Yes, Mithul, later you can do the exercise. Now you just count how many horizontal lines are there in this. Count us, Mithul. What is the count? How many? How many, Mithul? See, according to my knowledge, everybody had means they did not have any problem in volume 1 with the mic. But in volume 2, everyone is having problem with the mic. I don't know why. Yeah. Yes, Mithul, how many horizontal lines are there? I don't want to see that message. You unmute and then tell me. Mithul. Yeah, it's working. Yes, tell me.
9.
9 lines are there. Very good observation. Okay. So now 9 lines. Any objection for this? Any objection?
Ma'am, but the bottom two come within, I mean the lanthanoids and the actinoids, they come within the period 6 and 7, right?
Okay. So that means according to are there.
Yeah, 7 lines.
Okay, we'll study that. See students, okay, one horizontal line is like this, and second horizontal, fourth one, fifth one, sixth one, seventh one. There is only 7 periods. Okay, there are 7 periods. So what about according to Mithil? So his observation is actually good. So what about then you have to write it as 8 as well as 9, right? 8 as well as 9, right? But you just check the atomic number. Just check the atomic number. What is the atomic number? Students, it is 58. Okay, 58 and ends in 71. Ends at 71. So it is the continuation. See, 57 is there here. Then after 71, 72nd element is there here. That means between these two, lanthanum as well as between lanthanum as well as osmonium. These 14 elements are there. So that means this is a part of a sixth period. Similarly, you concentrate on this. This is 90, that is thorium, and lawrencium it is 103. So you just observe here, it is 89 actinium and 104 rutherfordium. So these 14 elements are there in between these two. So therefore, this is the series or else line from 7th period. So therefore, in the given periodic table, only 7 horizontal lines are there. So those horizontal, there only you write 7 horizontal lines are there. Those horizontal lines are called periods. Okay, horizontal lines are called periods. Is it clear? Totally 7 are there. It is not 9. So the 8th one as well as the 9th one, what you took account here, so that is actually a part of 6th as well as the 7th. Okay, continuation part. But then why you kept this one here? So I'll check 1 minute. I'll check participant list to see. See, there are some species like Vivek as well as Medanash. Yeah, some species are there, even Chirag, Anish. See, can you repair them? Even though I announce you have to keep your videos on throughout the class, can you repair them? No. So in chemistry class, it happens because in chemistry, for each and every statement, you will get contradiction. So similarly, these 14 elements are there, right? 14 sets. So 14 set as well as 14 set. They don't behave like these elements, like a D block. Therefore, we removed from this list and we kept it separate. Okay. So therefore, F is placed here. Okay. So then, students, you just take the count of vertical lines. How many?
18.
18. Okay, 18 counts are there. Then what about this? Once again, the same reason, don't count all these things. So this is a part of 6 as well as 7. So now students, this is the first group. So number is written here 1, and this is 2 students. Here you can you see 1A, 2A. So this is an old numbering method. So now we are not following this. So now we are writing it as 1, 2, 3, 4, etc. Here it is 13 and ends at 18. Okay, so there only, right? 18 vertical lines are there. Vertical lines. Those 18 vertical lines are called groups. That is called groups. Okay. So after this, see students, once again, what about that hydrogen? You kept it out. Why? Once again, the same reason. In some class, in the sense, in some reactions, its characteristic is similar to the first group. But in another class or else in another reaction, its characteristic is similar to the 17th group. So in some reactions, they don't behave, this hydrogen does not behave like the first group or else does not show similarity of this, okay, 17th. So therefore, this hydrogen is in a confusion. So therefore, we kept it out. So it does not show any periodicity. Okay, so or else property similar to periodicity means what? Periodicity means property similar to the other element. So one more thing. See students, why you kept sodium below lithium, potassium below this sodium, rubidium below this potassium? You can keep anywhere, right? But why you kept like that? Because that is due to the periodicity. Okay, so that is nothing but periodicity. What do you mean by periodicity? Periodicity means the elements having same physical as well as chemical formulas are listed in the under the same group. Is it clear? So now this lithium, sodium, potassium, rubidium, cesium, francium will show same type of characteristics. Maybe physically they are same or else chemically same. Chemical reactions are same. Physical reactions as well as chemical reactions are same. So therefore, we kept one below the other and that property is called periodicity. Is it clear? Now students will classify now. One more thing. And students, I think I have already informed you about representative elements in volume 1. Correct? So what do you mean by representative elements? If you consider chemistry, or else if you consider reactions, chemical reactions, inorganic chemistry, most of the reactions are related to either from S or else P block elements. Okay, so most of the inorganic reactions contains either S block elements or else P block elements. So therefore, S block elements as well as P block elements are collectively called representative elements. Remember, okay, are collectively called representative elements. Then over, then we'll classify something like metals, non-metals, etc. Students, this is a S block element. S block elements all are metals, all are metals. Okay, then this is a P block element. In case of P block element, you can observe some variations. See students, can you see the blue lines, blue color lines? So this is nothing but a metal. Okay, so then what about this green lines, green colors? So this is a non-metal, non-metal. Then what about, see, you include this boron also. Okay, you put a pink color for this also. So this line is there, right? This one. So this is called semi-metals, or else it is also called metalloids. Okay, or else one more thing is semi-metals, semi-metals, semi-metals. Okay, so now what about this D block? D block elements are called transition elements. Okay, D block elements are called transition elements because there exists. So it is the 1 minute. Okay. Let me retain this. So metal is there here, non-metal is there here. So this D block element starts from 3 and ends at 12. These 10 groups are in between metal as well as non-metal, and in its characteristic, see, if you check its a physical character as well as chemical character, it shows a gradual variation from metal to non-metallic in its character. So therefore there exists a transition, so therefore we name it as transition elements. Is it clear, students? Now what about this F block? F block elements are called inner transition elements. Okay, F block elements are called inner transition elements. Why inner? Why extra name is there? That is inner. Inner, why? Because it is a part of D block. So D block element is nothing but transition. So it is there. So this F is there inside this D. So therefore it is called inner transition elements. Okay, this is called inner transition elements. Is it clear, students? Is it clear?
Yes, ma'am.
Okay. Now we'll study group wise electronic configuration as well as period wise. Students, now let me take a S block. So S block contains 2 groups, right? Correct? If you concentrate on this, S block element contains 2 groups. Okay, so let me write the general group. So it is nothing but group 1 as well as it contains group number 2. So that means S block element group number 1 and ends at group number 2. Okay, so now this group number 1 elements are called alkali metals. Group number 1 elements are called alkali metals, and group number 2 elements are called all ortho metal. Are you able to follow, students? Is it difficult? No response. Did not get Muralidhar.
We can understand, ma'am. It's fine.
Okay. So now it is called alkali metals. What do you mean? What is the meaning of alkali? Students, remember, alkali is nothing but a base. Alkali is. Now here, if you consider alkali, say group number 1 element, you consider this group number 1 element reacts with oxygen and it forms oxides. Okay, it forms oxides, and it reacts with water. 1 minute. It reacts with water and will get hydroxides. Hydroxides. Did you study Lux flood theory? Acid base is over, right? Did you study Lux flood theory? Yes, right? So according to that Lux flood theory, both oxides as well as hydroxides of this are basic in nature. So you know what is in terms of oxygen donor. So now in this case, in group number 12, in group number 2, okay, so you consider group number second element, treat it with oxygen, it forms oxides, and treat it with water, it forms hydroxides. Both oxides as well as hydroxides are basic in nature. So you can also call it as alkali metals, but extra thing, earth is there. So here what happens? Corresponding oxides are there, right? Metal oxides, they are basic in nature. Okay, they are basic in nature and they occur in the earth crust. Okay, they found in the earth crust. So therefore the name alkaline earth metal. Is it clear? Okay, students, here only you write the general electronic configuration. So I'll rub all these things. Students, ES block, here two groups are there, that is group number 1 as well as group number 2. Group number 1, general electronic configuration is nothing but NS1. Write it fast. And general electronic configuration of group number 2 is nothing but NS2. NS1 as well as NS2. Students, now I have to write the general electronic configuration of S block. So it is NS1 to 2 because you can fill only 2 electrons in S. So in first group you can fill only 1 electron, and in the second group you can fill second electron, 2 electrons. So it is either, it contains, S block elements contains either 1 electron or else 2 electrons. So general configuration of S is nothing but NS1 to 2. Okay, then coming to the oxidation number, here only you write, it helps us to calculate or else to write the ions and all. Oxidation number, okay, oxidation number. Here oxidation in the sense it is a removal of electron. In both the case it is same definition for this, okay. It is a removal of electrons. Removal of electrons. Okay, removal of electrons. And now students, how many electrons you can remove? How many electrons you can remove? In the last bench or else in the valence shell, last bench in the sense valence shell, okay. So the last in the sense it is valence, okay. So it contains only 1 electron. So therefore you can remove only 1 electron. So its oxidation number, group 1 elements shows oxidation number or its oxidation number is equal to 1, plus 1. Plus 1. I will explain why it is plus, why it is negative. I will explain it later. Then in case of this second group, you have 2 electrons, okay, valence shell contains 2 electrons, so its oxidation state is plus 2. Okay, its oxidation state is plus 2. Now we'll study about, this is over, right? Then we'll study about a P block. P block. So P block starts from which group, students? P block starts from?
13.
Huh?
13.
Yeah, 13. Okay, group number, 1 minute, yeah. Group number 13 to group number 18. So this belongs to P block. Okay, group number 13 to group number 18. Students, I'll write the general electronic configuration of P. So that is actually NS2 NP126. This is the general electronic configuration of P block. General electronic configuration of P block. So here I have to study group wise electronic configuration. So I have, shall I rub this? Okay, 1 minute. I'll rub all those things. Students, NS2 NP126 is the general electronic configuration. Let me write the general electronic configuration of 3, 13, 14, 15, 16, 17, and 18. General electronic configuration of P is NS2. That means the NS2 in the sense innermost will be already filled. Okay. So you write NS2, it is common for all. Students, what is the number, how many number of P electrons will be there? Means electrons in P orbital, how many?
1.
1. So this is NS2 NP1 is the electronic configuration of 13. And NS2 NP2 is the electronic configuration of 14. Then NS2 NP3 is the electronic configuration of 15, NS2 NP4, NS2 NP5, NS2 NP6. Okay, I can't write here. So that is NS2 NP6. Okay, NS2 NP6. Now students, different names are there. So the last group elements, that is group number 18 elements, students, you just concentrate here. This is completely filled. S orbital, its capacity is full, and 6, that is P orbital, its capacity is also full. So that means the stomach is full here. So therefore you can name this as a lazy gas. Or else one more name is there. So that is a rare gas. Or else one more name is there, that is nothing but a noble gas. Okay, so why it is called like that, lazy gas or else noble? Because they contain completely filled, don't write stomach, completely filled atomic orbital. Okay, completely filled atomic orbital may be S or else a P. So its capacity is completely, okay, so that means 2 as well as 6, it is completely filled. Then group number 17th elements are called halogens. Group number 17 elements are called halogens. What is the meaning of this halogen in Greek? The meaning is nothing but salt producers. Salt producers. Then group number 16, its name is nothing but chalcogens. So the name is nothing but S, Nidhi, with whom you are laughing, I don't know. You are doing some other side business? No? Okay. Okay, no problem, no problem. So now chalcogens are there, right? Chalcogens means, see, in group number 16, you just glance this periodic table. So here in the group number 16, you have oxygen as well as you have sulfur. Okay, oxygen as well as sulfur is there, right? So now one more concept is that this in volume 2 you are studying that, you will study that. So that is nothing but a metallurgy. Metallurgy means what? You have to extract metal after mining. Okay, so you have to extract metal after mining, so using ore. So you know two things, I think you have heard this is mineral as well as one more thing is ore. Do you know something about this? Anything about this? No?
Mineral is the impure form of ore.
Okay,
But
so you will do mining, right? So after mining you'll get a chemical substance, right? That is called mineral. So it is a impure form. What about ore, whether it is a pure form? Muralidhar, whether ore is a pure?
I guess no.
Not at all. This is also impure form. Okay, ore is also impure. Then what is the difference between mineral as well as ore? 1 minute, I'll explain. See, you do extra mining, after that you'll get one chemical substance, or else it's actually, that chemical substance is named as mineral. So for example, if I consider iron, iron contains, okay, you can get different minerals, that is iron oxides, Fe oxides, and iron sulfides, iron carbonates, okay, Fe carbonates. So these are all the different categories, okay, different minerals of iron. Now your work is to extract, you have to extract iron from that. Okay, you have to extract iron. Okay, so students, extraction must be economical one as well as cheap. Okay, so if you study the data, then extraction of iron is easy. From this iron oxide, extraction is easy as well as it is economical one. But here in these two, if it is easy, then it is not economical one. Or else if it is costly, so that means two cases are there, right? Extraction must be easy and extraction must be economical one. So here it is not that, okay? Extraction may be difficult or else it is too costly, costly. So therefore, I will not consider, or else we will not consider these two as a ore of iron. So now we will consider iron oxide as a ore of iron. And we are going to extract iron from this ore. So this is the difference between the ore as well as mineral. For your information, mineral as well as ore both are impure form. Okay, both are impure form, both contains impurity. So ore is nothing but, there you have to do the extraction of metal, but that extraction must be convenient as well as economical one, convenient as well as economical one. Okay, over. So now students, this 16th group elements are called chalcogens. Okay, chalcogens because here you extract metal, sorry, you do mining. After that you will get a mineral, right? So chemical substance. So it contains most of the chemicals or else most of the metals are in contact with either oxygen or else with the sulfur. So see here, we have written iron oxides as well as iron sulfides. So since most of the minerals or else metals or else ores are in contact with either oxygen or else sulfur, so therefore in Greek the name is nothing but chalcones. Okay, so chalcone derivative, so sorry, it is generated from this chalcogens. Okay, so the name is like this. Over. Then we'll study about D block. So write D block element. Its general electronic configuration is n minus 1, D 1 to 10 and ns 0 to 2. You can also write ns is equal to ns2 because it is always completely filled. Okay, but one exceptional case is there at 47th element. So that is nothing but, here you just check, 47th is nothing but silver. Okay, so this one. So one exceptional case is there. So therefore we are writing it as ns0 to 2, ns0 to 2. Okay, so then the last one, 1 minute. Yeah, this one, F block. So its electronic configuration, general electronic configuration is n minus 2, F 1 to 14, n minus 1, D 0 to 1 and ns2. Over. Yeah, copper and chromium is exceptional. I will explain that electronic configuration, 1 minute. Otherwise, yeah, this is a general. I will explain it in detail now. So we'll check all these things. Okay. So now let me study whether this is done. Did you write all these two points?
Yes, ma'am.
Okay. So then, yeah, let me take yes block element. Students, I will select. So I have to study electronic configuration now. Okay. Yeah. First you write the side heading electronic configuration. Electronic configuration. Electronic configuration in periodic table. In periodic table. See students, this periodic table contains two things. That is nothing but a period horizontal lines as well as groups. So if they specifically ask down the group, okay, so how groups are there? Down the group. So the word, you have to use this word, down the group. Okay, then how period is arranged? Along the period. Don't make confusions. Along the period as well as down the group. So if they ask specifically how elements are arranged along the period, or else comments on the variation along the period, so you have to consider only the period like this, horizontal lines. Down the group means you have to write comment, you have to write the comment down the group, means vertical line. Suppose if they ask a periodic table, then you have to write both. Okay, because periodic table contains horizontal lines as well as vertical columns. Okay, students, now what do you mean by electronic configuration? Electronic configuration is nothing but distribution of electrons. Okay, distribution of electrons in different orbitals. Okay, so distribution of electrons in different orbitals, similar to your class. In class, you will be distributed in different benches, right? So same thing, same thing. So that is called, so don't write benches. Benches here, it is nothing but orbitals. Classroom is nothing but a shell. Okay, is it clear? So classroom is nothing but one shell. There's benches are there, right? So that is nothing but orbitals. 1 minute. Now, let me study electronic configuration down the group. Down the group. Electronic configuration down the group. Okay, electronic configuration down the group. Students? Students? Down the group. Okay, so let me take a lithium, sodium, potassium. So, okay, before writing this, yeah, you just make a cot mark there. Okay, I want to explain something else. So, which one is the longest period here? In this periodic table, which one is the longest period? Can you answer? Longest period, longest period. Okay, leave that question. Which one is the shortest period? Shortest period?
And sixth and
Sixth and seventh.
Sixth and seventh. Oh, so this is
First
answer for
one.
what? Yeah, first one is the shortest one, right? First one is the shortest one. Okay, so that means shortest period means it belongs to n is equal to 1. And the longest is nothing but n is equal to 6 as well as n is equal to 7, because it contains s, p, d as well as f. So it is the longest one. These two are longest. Okay, so this is the shortest. And what about this n is equal to 2 as well as 3? This is just short. You write it, it's short. Then what about the 4 as well as 5? This is a medium. Medium length. Okay. Over. Is it clear, students?
Yes, ma'am.
Okay. So now I will show you the. I will write one diagram here. Diagram in the sense how to fill the electrons. You write the same, students. So you start from the bottom. I have to write something up. Okay. So you write here 1s. 1s. Above 1s you write 2s, and here you write 2p. Then you write 3s, 3p as well as 3d. Students, turn on your cameras. Anika, what happened? Anish? Chirag? Shashank MN as well as Shashank. One more Shashank.
and the video is on.
No, it shows off.
No, I'm on.
Okay. Okay. So now 4s you write, 4p, 4d, 4f you write here. Then this is 5s, 5p, 5d, 5f. 6s, 6p, 6d, 6f. Next I can go up to 7, 7p, 7d, 7f. Students, always electron enters into lowest energy level. Remember, electron enters into lowest energy level. You show the arrow mark now. So this is the arrow mark. Then electron first electron enters into 1s orbital, then 2s, then 2p. Next to 2p, it will enter to 3s. You have one more. See, in higher classes, means in first year you will study this one. So n plus l rule is there. So there you have to calculate n. You have to take s value, n value, add those two, and you have to get the least number, less number. Okay. So this is like this. Then 3d, 4p, 5s, yes. Then 4d, 5p, 6s, like this. Okay. Then 4p like this, students. So write like this. So this is the method to write the, or else this is the way to distribute the electrons. Is it clear? Did you write all these points? Shall I rub?
Yes, ma'am.
What about others? Anaga, you are writing something?
I finished, ma'am.
Okay, so now I will write the electronic configuration of some elements. Okay, let me study electronic. You write EC. EC is nothing but electronic configuration. Okay, electronic configuration in group. Down the group. So let me take lithium. Below that I have sodium. Then you take a potassium. What is the atomic number of lithium? See, first 30 you have to study. Okay, in next class I will ask. First 30. Yeah. So, yeah, is equal to 3. Okay, Li 3. So, atomic number is equal to 3. What is the atomic number here? It is 11. What is the atomic number of potassium? It is 9. No, sorry, 19. Okay, so now you distribute the electrons. You just refer that energy level diagram. So now you have to place 2 electrons in S, so 6 electrons in P, 10 in D, as well as 14 in F. So what is the electronic configuration, students? Can you help me here? I don't know how to write. So can you help, Mithul? See, I'm observing. This is, I think this is the 4th background, Mithul. 4th background. One dark solar system, one more is colorful solar system, and one bridge came, one dog came. Next now, one more human being is there. Yes, what are you doing? You are playing with the background, right? Yes, I'm observing all, remember. And I will call to you, okay, Mithul, tomorrow you will get call, yes. See, lithium, atomic number is equal to 3. So what is the electronic configuration? So first you have to fill electrons in 1s. It is 1s2. Okay. Then whether I have to fill anything? Any other orbital? Students, just help me here.
2p1.
2p, 2p1. You just refer that diagram.
2s1.
Yeah,
2s1.
2s1. Similarly, can you write the electronic configuration of sodium? Yes, Mithul, you write it in your book and show it to me through camera. As well as write the electronic configuration of potassium fast. Yes, Mithul. What is the meaning? Maybe second one or else third one, no problem. But you are playing with the background, right? Yeah, that is truth. Yes, Mithul, I want to see your face. Yes. Yeah, now show me the book. Whether did you write that sodium electronic configuration? Faster. So you have to write it in your book, not through chat box. What it's black? Yeah, my screen is black only, okay? So my screen is black. I have written something on this in red. What, Mithil? So I told you to write electronic configuration in your book and show me through camera. You don't want, no need to share through screen. Screen sharing is not required. Yes, show me now. Okay, tomorrow, in next class, I will check. Okay, yeah. Yes, students, can you help me here? Anybody? Yes, Nidhi, can you help me? Yes.
For
Fast.
sodium, ma'am.
Yes. Tell me fast.
1s2,
Fast.
2s2, 2p6, 3s1.
3s1. Okay. So next, what about Keetan, Suman? Suman, can you help me here?
Ma'am, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1.
Okay. So now down the group, if you study, see, I have already gave that n is equal to 1 is nothing but k shell, n is equal to 2 is nothing but l shell, next is m, and next one is the last one is n. So in case of this lithium, electron enters into k shell as well as l shell. In case of sodium, electron enters into k shell, l shell as well as m shell. And in case of potassium, electron enters into k shell, l shell, m shell as well as n shell. So that means what conclusion you can write, students? Students, so what conclusion you can write? Down the group.
It's added down the group.
Yeah, down the group, write it. Down the group, electrons are added to different shells. Down the group, electrons are added to different shells. Over. So now let me study electronic configuration along the period. So now you just next side heading, right? Electronic configuration along the period. Okay, so I will take lithium once again. Lithium atomic number is 3, 1s2, 2s2, 2, sorry. 1s2, 2s1. Okay, so then after lithium, what is there? So I have to consider elements along the period, right? So after lithium, let me take a beryllium. After beryllium, I will take a boron or else carbon, nitrogen, oxygen, fluorine, anything you can take. Okay, so students, now beryllium, let me take a beryllium. What is the atomic number?
4.
4. Yes, so may they tell me the electronic configuration? Fast.
1s to 2s2.
2s2, yes, wait. Then next element is boron. Atomic number is 5. Tell me the electronic configuration.
1s to 2s2 2p1.
2s2, 2p1. Okay, so the next one is carbon. Tell me the electronic configuration.
1s to 2s2 2p2.
2p2. Okay, so one more nitrogen. So it is 1s2, 2s2, 2p3.
3.
Okay, so this is the electronic configuration, students. Okay, now here in case of lithium, electrons are added to K shell as well as El shell. Okay, here K as well as L, here also K as well as L, here also K and L, here also K and L. So what is the conclusion now? What is the conclusion?
Along the period, electron remains the same.
Electrons remains the same. Electrons increases.
Shell remains.
Shell remains the same. Shell remains the same. Along the period, electrons are added to same shell. Electrons are added to same shell, but the number of electrons it increases. Okay. Over. Is it clear? Is it clear? Okay, then I will give one. Yes, this is over. Then some exceptional cases are there in case of electronic configurations. Okay. So students, 1 minute. I'll give one set and there you have to find out how many electrons are there. So electrons are there in the valence shell. So that's electronic configuration is 1s2, 2s2, how much? 2p2. Okay, 2p2. Students, how many valence electrons are there? How many? valence electrons are there in this? How many?
4.
4.
Why it is 4? 4 or else 2?
Second shell there are 4.
Yes, valence electrons in the sense you should not. Okay, 1 minute, I'll keep it for charging. Valence electrons in the sense number of electrons which are present in the outermost, okay, outermost shell. Valence shell is nothing but the last bench, okay, and last bench students are called valence electrons. Okay, so yes, now you count here. So valence of shell is nothing but n is equal to 2 here. So that is the L shell. Okay, L shell. So this is a K shell. Okay, this is a K shell. This is a L shell. How many electrons are there? 4. So this is a valence electrons. Okay, yes. Now you know how to calculate the valence electrons and write chromium, its atomic. So this is about, okay. So s orbital is known to you, students. So 1 minute before writing this. See, you take a sodium, atomic number is 11, 1s2, okay, I will confirm this one first. Yeah, 1s2, 2s2, 2p6, 3s1. So this sodium belongs to s block because it's a valence electron or else the last electron enters into s orbital. Is it clear? Is it clear? Yes. Now let me take a magnesium. Its atomic number is equal to 12. So it is 1s2, 2s2, 2p6, 3s2 is the electronic configuration. Can you decide about group? Can you tell something about group? So sodium belongs to which group as well as magnesium belongs to which group by looking into the electronic configuration? Yes. So here this is of the type NS1, correct? This is of the type NS2. Is it clear? Okay, so therefore this is belongs to group number 1 and this is belongs to group number 2. You just check here. Yes, sodium belongs to group number 1, magnesium belongs to group number 2. Okay, similarly you take a next block is a p block. You just check the this one general electronic configuration. Now you take okay, fluorine. Let me take a fluorine. Atomic number is 9, so let me write the electronic configuration. That is 1s to 2s to 2p5. Okay, 1s to 2s to 2p5. So what is the general electronic configuration of p block, students? NS2, NP 1 to 5. Correct? Is it clear? NS2 means N value is equal to 2 here, right? This is of the type NS2, NP5. So more particularly, it belongs to 17th group. Correct? Correct? Yes. Students, shall I rub this? Amog, with whom you are laughing? Shall I rub? Anika, you want to write something? Write it fast. Over.
Yes, ma'am.
Okay, so now let me take a D block element and let me check the electronic configurations in D. Okay, so D block element. So you take take a chromium and write the electronic configuration. What happened, Medan as well as Shashank MN? It shows your cameras are off. Even Shashank Pujari. And who is this? Nidhi Baliga. Muralidhar. Who is this? Amog. Okay, so how to distribute the electron, Amog? How to distribute the electron? Amog, later you can talk. Now you give the answer for this question. Yeah. How to distribute the electrons? Amog, how to distribute the electrons? No answer? Why? Break is required. I did not give any break yesterday. No. Okay, so let me write this one first. So what is the electronic configuration here? It is actually 1s2, 2s2, 2p6. Okay, anybody? Anvita, can you help me here?
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4.
3d4. But it is not a stable electronic configuration, students. So what is a stable electronic configuration of this chromium? It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. That means one electron from the valence is shifted towards, okay? So okay, so it's shifted towards a D. Okay, so it is 3d5. Why? After writing this, you write the reason. Reason, students, you write like this: empty, empty, comma, half filled, and completely filled. Write it fully. Okay, so completely filled atomic orbitals are highly stable. Completely filled okay, empty, empty, or else half filled, okay, half filled, as well as completely filled atomic orbitals, okay, completely filled atomic orbitals are highly stable, are highly stable. So in case of S, empty is nothing but S0 and M completely means S2 configuration. So, and in case of P, P0 is the empty configuration, P6 is nothing but completely filled, half filled is nothing but P3. And in case of D, D0 is empty, D10 is completely filled, D5 is half filled. And in case of F, F0 is empty, F14 is completely filled, F7 is a half filled. So we are not considering anything here in S because it contains only 2 electrons. If you remove one more, it becomes a half filled. Okay, so half filled concept is not valid for S orbital. Half filled concept is not valid for S orbital. So students, if you get means empty configurations, or else if you get a half filled configurations, or else if you get a completely filled electronic configurations, these atomic orbitals are highly stable. Okay, highly stable. Is it clear? Okay, then I will continue this. Okay, students, therefore in case of chromium, so if you write the first electronic configuration, okay, the first first arrangement, then it contains 3d4, which is one electron less with respect to the half filled electronic configuration. So therefore one electron jumps from valence shell, yes, a valence shell or else a valence atomic orbitals to the innermost, means fourth bench to third bench, like that. Okay, so at that time you can get a half filled electronic configuration which is highly stable. Similarly, you write the electronic configuration of copper. So Mithul, if you write 3d6, okay, 3d6, then in case of iron, right? 1 minute, I'll explain that. Yeah. So students, yes, Mithul, can you help me here? Unmute yourself and then tell me the electronic configuration of copper.
1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10.
4, yes. Actually, we will write it as a 4s2, 3d9, but it is highly unstable, okay, because of you can shift one electron from the valence to the innermost. So you write it as 4s1 as well as 3d10 because completely filled atomic orbitals are highly stable. Okay, so then if you write Mithul, if you take this ion, its configuration is a 2s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d6 only. So you have to retain this. Rule is applicable only for the empty, half filled as well as completely filled. Okay, so they have extra stability. All are stable, but they have extra stability, only that much. Okay, so this is about the electronic configuration, students. Here, you just check. Okay, let me take a chromium first and just check the whether that general electronic configuration holds good or not. How to check? So what is the general electronic configuration of D? It is n minus 1d, correct? 1 minute. Yeah. So what is the general electronic configuration of D? It is nothing but n minus 1d, 1 to 10, n s 2. Students, in case of copper, what is the value of n? What is the value of n? 4. Okay. What is the value of n? N is equal to 4. So n is equal to 4 means, so how much? So you take this one, standard one. So 4, yes. Actually, this is 4s2. 4s2. Okay. So 4s2. Let me write the first one. Okay, first one 4s2. Later, the second one you are shifting to make it equal. You are shifting electron from the outermost to innermost to make it stable. So students, what about n minus 1? If the valence is 4, then a d electron enters into, yes, Shraddha, d electron enters into which orbital then? If a valence, yeah, tell me.
Can you repeat the question?
Yes, yes, I can hear.
No, like, can you repeat the question?
Huh?
Repeat the question.
Okay, so if n is the valence shell, here in case of chromium, n is nothing but the highest value is equal to 4. So I have written like this. Now the question is where d electron enters, to which orbital d electron enters. According to the rule, it says that n minus 1, n minus 1 means how much here?
3, the third.
3. Okay, 3. Okay, is it clear, students? It enters into 3D, right? So, but how many electrons are there? 4. You can have any number of electrons from 1 to 10. Is it clear? Is it clear? Yes. So, next you take, students, this is one more homework I will give. So, you take a F block element, F block. So, for example, cerium you consider, cerium. Okay, so you write the electronic configuration of this. Students, in case of F block, one more thing I have forgot to tell. So you have two periods. Okay, you have two lines there. First line is called lanthanoids, or else it is also called 4F series. Okay, the second series is called actinoids and it is called 5F series. Why it is 4F as well as a 5F? You pick one element and just write the electronic configuration. In case of lanthanoid, F electron enters into 4F atomic orbital, but in case of actinoid, F electron enters into 5F atomic orbital. 5F atomic orbital. Over. Okay, students, and now I'll study some important variations. So you have to study 4 important variations here. The next one is atomic radius. Atomic radius. What do you mean by atomic radius, students? 1 minute. Yeah. What do you mean by atomic radius? Anaga? See, only this is the first class, right? So I'm giving excuse. So from the next class onwards, if video is off, I'll throw you out. Okay? Later I will not admit you. Then don't make any call. Okay, so now students, atomic radius. Atomic radius means what? So you take one atom, and this atom you have a nucleus here. So here electron will be there. So here so many orbital, it may contain so many orbitals. Now atomic radius is nothing but the distance between the nucleus as well as the valence electron. This distance is called AR, in the sense atomic radius. Okay, so this distance is called atomic radius. That means, what do you mean by atomic radius? The distance between the nucleus to the valence electron. This distance is called atomic radius. If you want to sketch, you can sketch this. Over. Not a neat diagram, just to sketch a rough diagram. What happened, Chirag? As well as Anish, Anagha? Turn on your cameras. Okay, so the next thing what I have to study? So I have to study ionic radius. 1 minute. After atomic radius, I have to study ionic radius. What is the meaning of ionic radius, or else what is the definition? So it is the distance between the nucleus and outermost electron, that is nothing but a valence electron, till there, or else up to which, I'll write a complete definition, wait. Ionic radius. It is the distance between the nucleus, write it full, okay, nucleus and valence electrons. It's the distance between the, yes, Mithul. It is the distance between the nucleus as well as the valence electrons, up to which, okay, so till there, till valence electron, up to which nucleus has influence over electron. Okay, so it's not required. So till the last electron, valence electron, this nucleus has control. Okay, so that is nothing but ionic radius. Students, what do you mean by yeah, okay, Mithil. So ionic radius means you have to study something in ions. So how many types of ions are there, students? I'll rub this. How many types of ions are there? Do you know anything about that ions? Anybody? 2 types. What are those?
Cation and anion.
And yes, cations as well as anions. Students, see, total strength, it shows a participant list is actually 31. That means including teacher. So total 30 students are there. In this 30 students, okay, one exceptional species I got. So this is a Shashank MN. And one more is there. Yeah, Shashank MN only.
And my video is on from that time.
Oh, you are using this one instrument?
Yes, ma'am.
Okay. So I was checking only one. So there it was off. Okay. So then I don't have any exceptional cases in this class then? Okay, I don't have. Okay. So now students, The total strength of this classroom is actually 30 now, 30, okay, including teacher it shows 31. Now this teacher has to control all this 30 students, all this 30 students. So this is the original situation, so or it is also called parent atom, parent atom. Now let me remove someone from this. Okay, so let me remove Amit because I can't see his face. Yes, now it is visible. So if I remove him, if I remove that Amit, or else, so now you have to consider that student as electron, teacher as nucleus. Okay, so now if I remove him, what happens? Strength decreases, strength decreases. What happens to the size? Size decreases. At that time teacher has to control only 29 students. Okay, 29 students. So this is the situation of the cation. I will explain how to write the positive charges and all. So now one more thing is there. If actually see, now the strength is only 29, I have to control, yeah, it is increased now. Okay, so I have to control only 29 students, so the size decreases. Now if I add one more student or else one more electron to this parent atom, what happens to the size? It increases, it gives a 31 count. So this is a nucleus, or else teacher has to observe has to observe all 31 students. So what happens to the size? Size increases. So this is a case of the anion, students. I'll take a parent atom, parent atom. So if you remove electron from this, so students you can write this one. 1 minute, I'll write this. Yeah, you take a parent atom. Okay, this is a parent atom. Now from this you remove electron. Students, minus electron is nothing but a removal of electron. Then write it a small size. Okay, size decreases, size decreases. So now if you remove electron, you will get a cation, positively charged species. Size is small, size is small. Then students, to the same parent atom, you add one electron, add one electron. When you add one electron, then size increases, size increases. So this is a situation of a negative ion. See, cation is a positive one, positive, anion is a negative. Its size is large or else big compared to that of the parent. Compared to that of the parent. Is it clear, students? Now, what do you mean by ionic radius? What do you mean by ionic radius? Ionic radius can be defined in cation as well as anion. So it is the distance between the nucleus as well as the outermost electron or else valence electron. Till here, this nucleus has control. Okay, so now in case of this, see, till here, why we are mentioning that till here nucleus has control? Why that word is there? Because atomic radius, you concentrate on the atomic radius. Atomic radius can be explained in the parent atom, correct? So now in case of this cation, you have removed one electron. You have removed one electron. If I throw one electron out or else one student out, at that time other students will be attentive. Correct? At that time the attraction or else the influence is more. Influence is more. Yes, Muralidhar, you are playing now. I can understand. I can throw you out. So at that time I have to concentrate only on the remaining 28 students. So it helps me to concentrate more. Means still there the teacher has an influence. Okay, or else a nucleus has an influence. So it is called ionic radius. And same thing here in case of anion, students. So this is clear, right? Okay, so now let me define covalent radius. Okay, so covalent radius. What do you mean by covalent radius? So students, I'll write, say exact definition you can refer from your book. Okay, so let me write a one molecule. So this is atom A, this is atom B. They combine with each other to give a molecule. More special name, so a particular special name is there for this. That is nothing but compound, because two different atoms are combining. So if same type of atoms are combining, then you can name it as molecule. So okay, now let me take, okay, imagine this, both are same. So now let me remove that and just you remember this as a molecule. So now covalent radius name itself indicates that this is observed in non-metals, mostly in so most probably it is in non-metals or else in p block elements, because their electrons are shared between two elements. In case of S block, electrons are completely transferred. So you are going to get ionic bond there. In case of S block, correct? Yes? Do you know something about bonding? No? If not, you will study this in this volume. Okay, so now the distance, you combine these two, so what is this? This is a diameter. So what is required now? It is a radius. So a radius is nothing but the one half of the distance between two covalently bonded atoms, means one molecule. So this is nothing but covalent radius. Now students, I have to study metallic radius.
Excuse me, ma'am.
Yes.
If the same atom is bonded to two other atoms in a covalent bond, do we define covalent radius for each of the bonds?
Covalent, one molecule you consider, there you are defining the one radius. That means you give the situation. So you are,
For example, in carbon dioxide.
like this, carbon dioxide. Okay, carbon dioxide is carbon as well as oxygen. So you'll write like this, right? So, and you have to check the octet rule here. So here also you have a covalent bond, and here you can define another types of sets, that is sigma bond as well as pi bond. Covalent radius or else covalent bond is observed when there is a sharing of electrons. See, in case of carbon dioxide also sharing of electron is there, right? So it forms covalent radius, and you can also define, covalent bond, you can also define covalent radius. Okay? Yeah. Now I have to study metallic radius. What I wrote here? Metallic metals. No, it is metallic radius. Okay? Metallic radius. Students, so what is the difference between covalent radius as well as metallic radius? There is no difference. Exactly same. Okay, it is the one half of the distance between the two covalently bonded, but here in case of a metallic, you have to write it as a ionic bond or else a metallic bond. So this is nothing but a metallic radius, but it is observed in metals. That covalent bond is observed in non-metals, and here you can also see this bond means complete transfer of electron, that is nothing but ionic bond. You can see that means complete shifting of electron is observed. Complete shifting of electron. Over, but what is the main difference between covalent as well as metallic? Metallic is observed in metals, covalent is observed in non-metals. In case of covalent radius, you can observe covalent bond. In case of metallic radius, you can observe ionic bond or else metallic bond. Over. Shall I rub this? Yes, Anika, fast. Over. Yes. The next situation. Next situation, you write van der Waals radius. Van der Waals radius. Van der Waals radius means it can be expressed in two molecules which are placed adjacent to each other. This is the nucleus of these two. Combine these two. This is the nucleus of these two. Combine these two. So now you combine these two also. Okay. Now this is the 1/2 of the distance between two covalently bonded molecules which are present adjacent to each other. Is it clear? Did you get something? No? So it is 1/2 of the distance. So what is the difference between covalent as well as van der Waals? In case of covalent, you are taking one molecule. In case of this one van der Waals, you have to take two molecules. Okay. See, in case of this covalent, you are taking one full set, one full molecule. Then half of the distance you make, okay, imagine, okay, this is one molecule. So one atom, this is one more atom, this is a molecule, okay. So half of the distance of this is called covalent, okay. So now to explain van der Waals, you have to take two molecules, okay. You have to take two molecules. Now, okay, you remove this, but I have only two hands, I can't hold everything, okay. So yes, actually atom is there here, atom is nothing but here, one top, one more top, that is nothing but two atoms, they combine with each other, okay. Then 1/2 of the distance between these two molecules is taken as a van der Waals. Is it clear? Okay, 1/2 of the distance in single molecule is nothing but, okay, I have 1 minute, I'll write here. See, 1/2 of the distance, 1/2 of the distance between two nuclei of the single molecule is called covalent. Then you take, to define van der Waals, you have to write two, you must have two molecule, okay. So now combine all these four, or else you can leave, you can combine these two, okay. So now 1/2 of the distance between these two are called van der Waals, okay, are called van der Waals. Now this is the structure, or else van der Waals radius. Is it clear, students? Is there any doubt in the van der Waals as well as covalent? Anika, question mark is there in your face? No? Did you get? Okay. So now we'll study how atomic radius varies along the group as well as down the group, along the period as well as down the group. Okay. So next you write, students, variation of atomic radius down the group. Variation of atomic radius down the group. Okay. So now students, down the group. Okay. So you consider your classroom concept, and you know the thing, electronic configuration, just glance electronic configuration which we have arranged or studied down the group. How electrons are added? Electrons are added to Amit. Electrons are added to
Electrons.
Electrons are added to Amit.
Valence shell, ma'am.
Yes, sir. Very good answer. Electrons are added to valence shell always. If you consider any element, it will add there only. You don't have a other place. Now I'm asking down the group how it varies.
Ma'am, you're meaning the...
That means you are talking, right? So therefore you are not getting meaning. Yes, Muralidhar, later you can do the exercise. Yes, Amit, you just glance that periodic, 1 minute, yeah. You just glance that electronic configuration, how we studied it down the group.
Ma'am, 1s2, 2s2, 2p6.
Oh, don't tell
Then-
everything. I can't understand everything, okay? So you tell me the elements. There we took lithium, sodium, potassium. And I wrote something there. Did you write those things? Yes, Amit? No? Yeah. So that is nothing but 18th group element. Correct? You are acting like 18th group element. Correct? Yes. We don't want 18th group elements. They are chemically inert. We'll throw them out. Yes. Students, now you imagine your classroom situation. Okay? So now you just check here. See, teacher is there here. Okay, teacher is there here. Now, in classroom, so if you study down the group, okay, so down the group means different benches are there. This is one row, this is second row, like that. Different benches are there, right? So now, down the group, how electrons are added? Down the group, let me write here. Down the group, okay, so down the group, electrons are added to, Amit. Down the group, electrons are added to different shell. Write this one. Different shells. Okay. So down the group, electrons are added to different shells. Okay, different shells means different benches. Shell is nothing but bench. Okay. So now students, now teacher is sitting here. Which shell is nearer to me? Which bench is nearer to me? The first bench, right? So first bench. So down the group, what happens to see this one atomic radius means what? See, we are studying the variation of atomic radius, right? Atomic radius. Now, if I stay here, this is a nucleus. Can you? Yeah. So this is the position of the teacher. Okay. So now one molecule is sitting here next to me. That is there in the first bench. First bench. Can that molecule sleep in the class? No. So if he is not interested also, he must act like listening because teacher is there here, nucleus is there here. You consider you equate that teacher to nucleus, electrons to students to electrons. Now one more student is sitting in the last bench. Okay, last bench. So he may write or else he may do some other business. Okay, some other business. Actually, this is a chemistry class. He may write some problems. He may solve some problems related to maths also. Okay, why it is so? Because teacher is there here. Correct. So different benches are there. It's a valence bench, means last bench, or else a valence shell, last bench. So electron is there here. What about the controlling capacity? It is actually less. Not in my case, okay? So it is less, okay? So effective nuclear charge is less at that time. See, you consider one classroom. Imagine one door is there here and one more door is there here. So now what happens? This electron may escape from here. Correct. So now what about the effective nuclear charge? Effective nuclear charge is very less, that electron cannot jump from the college. So college compound is there, only one door is there, yes one gate is there, right? So it has to roam somewhere in the veranda, okay? So corridor, but it is out of this complete set. Okay, this is one atom, one nucleus is there. Okay, so here one electron is there. So you consider one electron in the first bench, one more electron in the last bench, means valence bench. Here, this electron or else this student is under influence or else under control. Effective nuclear charge is very high. So now, in this case, effective nuclear charge is very less. Correct? So now same thing, you consider down the group how electrons are arranged. Electrons are added to different energy levels or else different shells. Now nucleus is there here. If you add electrons like this, okay, n is equal K shell, L shell, M shell, N shell, sorry, K, L, M, N. So if you add like this, so K shell is under influence of this nucleus. What about L shell? Influence is a little weak. And what about M shell? Once again it is weak. And what about N shell? It is very least. Correct? So what happens? The size, okay, or else 1 minute. So this is the position of teacher. What happens to that last electron, last student? The distance between the teacher as well as the, or else nucleus as well as the last electron is high. Okay, the distance is large, or the gap is large. So at that time, effective nuclear charge is less. Okay, effective nuclear charge is less. Effective nuclear charge is less means what happens to the radius, size? Size increases or else decreases, students?
Increases down the group.
Size increases down the group, students. So you write the conclusion. Down the group, electrons are added to different shells. Next, what is your observation related to effective nuclear charge, or else what do you mean by effective nuclear charge, friends? It has a controlling capacity of what? Of nucleus. On what? On electrons. Okay, valence electrons. Till valence electron, till last bench. Teacher has to observe all students who are sitting in the last bench. Okay, so that is nothing but valence shell. So now here you can write effective nuclear charge. Effective nuclear charge, what happens? Effective nuclear charge is decreases, less. What happens to the size? Size increases. You write, remember these three reasons. Okay, so down the group, electrons are added to different shells or else different energy levels, and effective nuclear charge decreases down the group. And what happens to the size? Size increases. Size increases. Over. Now what is the time? 1 minute. 26. Yes. Now you write variation along the period. Along the period. So now students, okay, this is like this. One teacher is there here, one bench is there. You are adding electrons to the same shell. Correct? Same shell. So now how we have seen the electronic configurations, right? So how electrons are added along the period? So you write here, along the period, Muralidhar, along the period, electrons, Amit, electrons are added to, electrons are added to same shell. Correct? Same shell. You just glance that electronic configuration along the period. So same shell. What happens to the effective nuclear charge, students? Electrons are added to the first bench. Electrons are added to first bench. What happens to the effective nuclear charge, students? Tell me.
Increases.
Effective nuclear charge is high. Increases. High. What happens to the size?
Decreases.
Decrease.
Size decreases with respect to the group. Okay, so this decreases in the sense with respect to the group. Okay, so size decreases along the period. Okay, size decreases along the period. Is it clear, students? Is it clear? So how size varies down the group as well as along the period? Is it clear? Any confusions in this? If it is so, if it is confusing, you connect that teacher as well as the first bench as well as you increase the bench. Okay, so one bench is nothing but one shell. So like that you remember. Yes, students. So but chemistry, right? For each and every dialogue there is a contradiction. Amog, there is a contradiction. See, this is a chemistry class, right? I'm telling. So there is a contradiction. He is acting like, yeah. With whom you are talking, Amog? What is this, Amit? Question mark. Size of atom I did not get. You have mic, unmute and then tell.
No, ma'am, the doubt got cleared, ma'am.
Okay. So now in this there are some exceptional cases. So that exceptional cases is due to the presence of, so 1 minute. See, if a nucleus is there here, nucleus is there, then the very nearest orbital is nothing but which one? SPDF is there with you now. The nearest orbital is nothing but, students, you write this one. This is a S orbital. Okay, so the next one you can have a P orbital. Next one is D and next one is AF. So in case of S orbital, it is very nearer to the S orbital, nucleus. S orbital is very nearer to the nucleus and it is difficult to remove electron from S. It is easy to remove electron from S. So if you study electron removing capacity, or else it is also called penetration power. penetrating capacity or else penetration power. Penetrating capacity. Okay, penetrating capacity. So it is very high for P, less for very high for S, less for P, less for D, less for F, least for F. Okay, so now students, in case of s orbital 2 electrons are there, in case of p it is 6, in case of d it is 8, and it is sorry, in case of d it is 10, and in case of f it is equal to 14. Now students, one more concept I want to clear here. I want to tell. I did not get. Ma'am, is it electron removing or electron remaining? It is difficult, so Sumedh. It is like this. See, this is a nucleus. Okay, this is SPDF. It is easy to remove electron from F because distance is more. It is easy to remove, but it is difficult to remove electron from S. It is easy to remove electron from S. Okay, it is difficult to remove electron from S. So what I told, if it is easy to remove electron from F, it is difficult to remove electron from Es. Is it clear? Because effective nuclear charge is very high. Here effective nuclear charge is less. As the distance increases, effective nuclear charge decreases, Mithul. Okay, effective nuclear charge decreases. Okay, so students, now one more problem is there. Teacher is there here. So many benches are there. And the last bench, only one electron is sitting. So how many valence electrons are? This is a valence bench and valence shell. And valence shell contains only one electron. So valence electron is nothing but equal to 1. Okay, equal to 1. Now here 10 students are there. Imagine 10 students are there. That is all from d orbital. All are from d orbital. Okay, if 10 students are there here, imagine this electron is sitting, last bench student is sitting, here teacher is there, here all students are standing. How many students are there? 10 students are there. At that time, what about the effective nuclear charge of this nucleus on the last electron? It is less, right? Less, right? So now if I say something, then this electron, valence electron, is not able to listen anything. Okay, why? Because of this block. Because of this block. So this block is called shielding effect. Shield. Okay, shield is nothing but a block. So that effect is called a shielding effect, or it is also called a screening effect. It also affects the atomic radius. Okay, we'll study it in next class. Students, you just write effect of screening or else shielding on the atomic radius, or else I'll explain the shielding effect once again in next class. Okay, Sumedh. Students, do you have any doubt? And tomorrow as well as day after tomorrow, you don't have a regular class, but you may get orientation class. Will announce it later. Don't make any calls. Okay, and if you have any problem, you have to send a mail. Is it clear? Yes, students, read well, glance it once, and we'll meet on, I think, Saturday. Yes. Yeah, Mithul. Yes, welcome, students.